Question 45B from your homework asks this. For each of the following unbalanced reactions, suppose exactly 5 grams of each reactant is taken. Determine which reactant is limiting, and also determine what mass of the excess reagent will remain after the limiting reactant is consumed. I wanted to just break that process down for you guys because a lot of what you have to do is very similar to this for this homework assignment. So first, start by writing out the unbalanced equation. And this is actually a reaction that you have done in past labs. CaC2 is calcium carbide, and that was a black solid. And then you would place a few drops of water that would rapidly produce acetylene gas, so that C2H2 product on the right-hand side. All right, so when you're doing this, the first thing you always want to do is to make sure that the equation is balanced, even if it doesn't tell you that in the equation that it's unbalanced. Make sure you're double checking that first. So I went ahead and put a 2 in front of water. Also note that I rewrote water as HOH. Again, a reminder to you guys to make hydroxide compounds easier to balance. You can write water as HOH and then balance the hydroxide and hydrogen separately. All right, what I like to do is I like to write down how much of each reactant I have. So I started by doing that, and I wrote that 5 grams underneath each one of those. And then I had to make a decision as to which one I thought might be the limiting reactant. Again, it's okay to start off with just one by a guess, but sometimes you can make a really strong educated guess. If I did a really quick comparison, since I'm starting off with equal amounts of each, and I just look at the molar mass of calcium carbide and then also the molar mass of water, even though I need twice as much water as I will need calcium carbide, the fact that the molar mass of calcium carbide is so much greater than water, there's a really strong chance that CaC2 is actually going to be my limiting reactant, and that's why I started off with that. So I put 5 grams of CaC2 over 1, and then I am going to divide by the molar mass of calcium carbide to get how many moles of CaC2 I have. The next step, as always, is to use the mole ratio, so putting the moles of CaC2 on the bottom so that it will cancel out over here. And then I have 2 moles of water that will be required. And then our last step to figure out grams is always to multiply by the molar mass of the compound we're looking for. And so here we're comparing calcium carbide to water. Putting 1 mole of water on the bottom so that the units cancel out, and then 18.02 grams of water on the top. Again, that's the molar mass of water. Hopefully you have that memorized at this point. We've used it quite a bit. When I run that calculation through the calculator, I get 2.81 grams of water. Now again, part of stoichiometry is understanding what that number means. So 2.81 grams of water means how much water would be required in order to completely use up all 5 grams of the calcium carbide. Do I have 2.81 grams of water to use? Absolutely. I started off with 5. That means that calcium carbide is going to be my limiting reactant, so my educated guess was accurate. And then the second part of the question is asking how much of the excess reactant will remain. So again, in the previous video, we talked a little bit about how to do this. You just take the 5 grams minus the grams of water that would be required, which was 2.81. The answer that you will get is how much will be left over. So 2.19 grams of water will remain in excess. Now this problem doesn't ask for it, but if we were to be asked an additional follow-up question, like how many grams of calcium hydroxide would be produced, or how many grams of C2H2 would be produced, we would have to use the limiting reactant only to determine that. So we wouldn't do anything with the water. We'll just use the limiting reactant of CaC2, and we go from 5 grams and we figure out how many grams of this or how many grams of C2H2. If we wanted to use the limiting reactant, we could, but we would have to use how many grams of water would be required, not how many grams of water we would actually have started with. Why I typically tell students not to do that is if you made a mistake here, it could be a really small mistake, and you're basing your next answers off of your limiting reactant, off of your excess reactant, you can make additional errors down the road. So it's always better to start off, determine the limiting reactant, and then figure out from there what your excess reactant is. Use your limiting reactant only to determine how many grams of product you will be producing in that reaction.